phase or all three of them across. So you could feed single phase, tapping off of two phases, which again is more power, more capability, or single phase to ground. Either of the, okay, one is going to be, for example, at a 480 voltage, I'm going to have three-phase 480, I'm going to have single-phase 480, and I'm going to have single-phase 277. Well, that's very, very common and used for lighting in a building, for example. They make a lot of lighting fixtures at 277. Okay, if you've got a 120 208 transformer, you can feed small motors with two phases of the three. You can feed a little bigger motor with all three phases of the 208, or you can feed receptacles, for example, or 120 volt lighting circuits taking a phase to ground. So it's not unusual to use three phase to supply a lighting panel that'll do a number of different things. Okay, so that's the advantage of having the Y-connected secondary feeding a panel, because it gives you the options to tap off different voltages, different amounts of power. And, you know, we talk about instrument transformers here. Now, let's talk about the auto transformer. All right, the auto transformer, I just happen to have one here, but that's okay. Basically, if you look at that picture, and as you would, it has a single coil. It doesn't have two coils, it only has one. The primary is coming in and energizing the whole coil. Well, think of it as running your thumb up, keeping your one finger down there and running your thumb up and stopping wherever you want. The more coils you're cutting, the more voltage you're getting. Okay? So this would be a transformer that's variable pretty much as you want it to be. It can go 1/10 of a volt at a time, just pushing it along a little bit at a time, and there's a little dial on the top of it. So if I want to have 24 volts, whoop, I dial it up to 24. If I want 120, I can dial it up. Now I can get them in up to 480 volts if I want. We've got one at work that's a three-phase 480 volt that I can tap it from 0 all the way up to 480 volts. Okay. Don't use it a whole lot as far as testing is concerned, because most of our testing is done in single phase, not three phase. However, there are applications, so that's why we have them. For example, we use it to take a three-phase variable frequency drive and to recharge, I'm not using the right word here, but basically recharge the capacitors, because when they sit around sometimes, especially in high temperatures, they tend to not work so well. So the manufacturer recommends that you go and reconform them, I believe they call it. And we do that by applying a voltage and backing it down slowly, and applying a voltage, backing it down slowly, and getting them to a point where you can get them up to where they were supposed to be. Okay, and then so this would be a three-phase. Okay, this first one up here, what we call in the industry, we call it a Variac. Okay, because we can vary the voltage from 0 to whatever the maximum is. The one I've got here, even though you plug it into 120 volts, I can actually get it up to the point that by tapping past that upper tap, I can get 150 volts out of it. So, believe it or not, there's different ways of skinning the same cat. Then a three-phase, again, you could use that to vary the voltage, starting up a motor, You could have it something that's wrapping up and automatically raising the voltage as you try to start a motor. Along down here, we have a current transformer. Very common way of feeding, for example, a ammeter. Let's suppose I have a motor that's got 200 volts, I'm sorry, 200 amps. Well, yeah, you probably don't want to put 200 amps into a little tiny ammeter, okay? Or else you're going to have a great big ammeter to be able to handle the 200 amps of power that it's going into. So what they do is they take an ammeter and then they have a single conductor that's got the primary current in it. They take a number of wraps, and the number of wraps of it will give you a ratio, and that ratio is used to reduce the range of a gauge by whatever that ratio is, 1 to 10, 1 to 100, whatever. So there's lots of different shapes. They're almost always round, helical sometimes. I've seen many different types of different current transformers. Okay, this would be a potential transformer. What's a potential transformer? It's a transformer. It's got step up, step down. Typically it's step down. If you've got a 44,000 volt system and you want to get it down to 110 volts, you need to step it down via a transformer. Why do you want it to get down to 120 volts? Because that's what I'm using in the instrument that's protecting, for example. It's using that ratio and looking at the actual current, using that multiplier and figuring out what the line voltage is, what the line current is, and then using the multiplication factor in there. It'll trip at a certain set point. It'll look at, for example, a load of a motor, and if it goes above, maybe 10% above nameplate for a certain amount of time, trip. Okay, if it spikes, they have an instantaneous trip, kind of like what they call a magnetic trip. If the magnetic field gets so high, it just trips it immediately. And those trips can be very instantaneous, to the point that, for example, if you try closing a breaker into ground, you'll think that it never worked, but it did. It closed and opened just so quickly that it felt like it never closed to begin with. All right, so that's talking about the different types of transformers. I think that's about all I'm going to cover on the subject at this point.
And that would bring us up to chapter
Okay.
4 for next time, right?
Correct.
Okay. We'll join you then. Have a good one, y'all.